Hello. Yes, good morning all. Today we are looking for the lab practicals of a subject system programming and operating system lab. We will be covering two lab experiments in this case. The first is B2 and B3 from the B group. The first programming is write a program using lex specification to implement lexical analysis phase of compiler to generate tokens of subset of .java program. And the second is write a program using lex specification to implement lexical analysis phase of compiler to count number of words, lines and the characters of a given input file. Before this, we will have a look on the lexical of what is a lexical analysis. So let's have a background for this. Let's have an overview of this. So we have a high level language as an input given to a preprocessor, and this preprocessor converts a program into a pure high level language. Now what does this pure high level language is? Generally in our programs we include hash include, or we have macro definitions also by having a hash define. These macro definitions or hash include files will be placed as it is. It means that suppose I am including something like hash include stdio.h. In a pure high level language, the complete file will be included in the source code. In a similar manner, if I have a macro definition somewhere and that macro has been called from a program, so in a pure high level language that complete macro will be replaced in a program. So this pure high level language code will be input to a compiler, which is going to convert that pure high level language code into a assembly language. Now this assembler, what does this assembler do is assembler takes a assembly language code and convert it into the platform specific language. Now this platform means a combination of hardware and operating system. A hardware can be something like Intel, AMD, Motorola, and on the top of it we can have various operating systems like Linux, Windows, 32-bit versions, 64-bit versions. So these assemblers are different for different platforms, and the assembler has an input of assembly language code and then it converts into the machine language code. Now these machine codes are zeros and ones. Still there are two types of machine codes, which are relocatable machine codes and absolute machine codes. These relocatable machine codes are the codes which loads a machine code at any point in a RAM and execute. It means that there is no fixed memory location of the RAM given to the code. It can be loaded at any point and it can be executed from there. The loaders and linkers takes this relocatable machine code and converts them to a absolute code. So these are all the overview of how the high level language is converted to the absolute code. In all compilers like GCC, etc., this part, these all phases are included in that compiler itself. So this for example in GCC we do not provide the pure high level language, right? We give a code which is having the hash include, which is having the macros and which is getting expanded and then converted internally, and directly we get a output file. So this is what is overview of how our codes is getting executed. Now we will see phases of a compiler. This is actually a background of how the lex and ACK works. So these are all the phases of compiler. What we have is a high level language input to a compiler. The first phase is a lexical analyzer. This lexical analyzer takes a program and convert it into a tokens. So it generates a stream of a tokens. This stream of a tokens is given to a syntax analyzer, which is also called as a parser, and this parser generates a parse tree. Now this parse tree is given to the semantic analyzer. This semantic analyzer verifies whether the parse is meaningful, this parse tree is meaningful or not. It means it checks whether it is syntactically correct or incorrect. Then it is given to the intermediate code generator. It generates a 3 address code. Then which is given to a code optimizer. Code optimizer reduces the size of a program, and then it is given to the target code generation, and which generates the assembly code. This is all is the phases of compiler. It takes a support from a symbol table manager, and it talks with the error handling module. So this is all about the compiler. So more details are given at this link. You can refer the link and look at the more details of the phases of compiler. Now we'll look what is a Lex. A Lex is a computer program that generates a lexical analysis, and it is written by Mike Lex and Eric Smith. It reads the input stream specifying the lexical analyzer and outputs a source code implementing the Lexer in the C programming language. We use in our coding or in our lab assignment is a Flex. Flex is a fast lexical analyzer generator. It is a tool which is written by Vern Paxson in a C around in 1987, and the Flex and Bissons are used in cooperation of each other to manage the lexical analyzer and semantic analyzer phase of the compiler. Now we'll see how the Flex works. So this Lex takes the input file, which is in a form of .l, as a source program. So the input to the Lex compiler is any file with the extension .l. Then Lex compiles it and generates a lex.yy.c file. It always have the same name. This file will be given to the C compiler, and then C compiler converts, it takes the input stream and then gives us a sequence of tokens as a output file. So what happens generally is input file describes the lexical analyzer to be generated, named lex.l, is written in a Lex language. We'll see a Lex language later on. The Lex compiler transforms lex.l to C program in a file that is always named as lex.yy.c. The C compiler compiles this lex.yy.c file into an executable file called as a.out. This output file a.out takes a stream of input characters and produces a stream of a token. So this is how the Lex works. There is a specific program structure for the Lex to be written as. The first, there are 3 sections. The first section is a definition section, and the syntax is given as this, that is percentage curly braces and end, which again a percent and curly brace. So anything written in these brackets is copied directly to the file lex.yy.c. The next section is a rules section. This is an important section where we actually give the rules. So for example, this is a pattern 0 to 9. So what does the rule? This is for all digits between 0 and 9. Take this second last example, that is into bracket we have a hyphen z and capital A hyphen capital Z. So this is any alphabetic letter. So these are the patterns which are used for the rules section of the lexical analyzer, and these patterns are matched with something. So take example, we have A star. It means 0 or more occurrences of A. Similarly, we have A plus. It means 1 or more occurrences of A. Suppose we have a negation A, it means all other characters except A. So there are multiple patterns which are available to given for the rules section. And the last section is a user code section. In this user code section, it contains a C statements and additional functions. We can also compile these functions separately and load with the lexical analyzer. So this is how is the program structure for a Lex file. There are few predefined Lex variables. So these Lex variables are yy Lex. So this is function, it calls the lexer and it returns the token. So this is the important function which has to be called from your .tel file. So in turn, which will be calling your lexer and which will be processing your file, and you will get a token in return. We have a char star yy text. This is a pointer to match a string. So whatever token has been returned, that is called as a match string, and this yy text is going to pointing to that particular token. We have yy length, so length of the match string. Then we have yyLval, which is the value associated with the token. Then there is a ywrap function which says that it is a wrap up function. So if this function returns 1, it means you are done with the parsing a file, and if it is returning 0, it means that you are not done, you want to parse few more files as well. Similarly, we have file star yyOut, file star yin. These are all input and output files. Then we have initial, begin and echo, which is to match to the initial start condition, switch start condition, and write match string. Then how to run this program? We have to run this program by saying lex and filename dot l or lex filename dot lex, depending on how you have saved the lex file. Then this is going to generate, this first step is going to generate lex.yy.c file. So that file has to be compiled with GCC in step 2. So step 2 is GCC lex.yy.c, and the step 3 is execution of our output file, that is ./a.out. And then if you want to provide the input file, in this case you can provide the input file as well. Now we'll look at the code. So this is our code. We will have a look of the code. So what does the code says is, it is again divided into 3 sections as given here, and the first code we are looking for is write a program using lex specification to implement the lexical analysis phase of a compiler to count number of words, lines and characters. This is a B3 experiment in a SPOS lab, all lab experiments. So what does this do is, this first section we can see, this section is a definition section. As we already know that we are supposed to give different definitions in these sections. So whatever variables I required, those variables will be declared in these sections. This section will be directly copied in your Lex code. The next section is my rules section. So this rules section informs me about what are to be rules used for a given code to generate a token. In this case I have used few rules. The first rule is it is a /t. So this means that it is a tab. So what I will do is, I will be incrementing this tab variable, because I want to count how many number of tabs are there in my input file. So once I encounter /t, I will be incrementing the counter which is given for tab. Next, if I encounter with /n, a /n means a new line. So if I encounter /n in my input file, I will be incrementing a new line variable. Then I have a space, because this is a square bracket and there is empty square bracket. It means that there are the white spaces. So once I encounter with a space, it means I am counting it for the white space. So I will be incrementing this white space counter. If I encounter 0 to 9, any character and any number of characters between 0 to 9, I will be incrementing a number counter. With that, I am incrementing the length, I am incrementing the D counter also, that is a lines counter. You can see here the D counter is a digits counter. So if I encounter a number which is between 0 to 9, I will be incrementing a number counter, and whatever is the length of that particular token, with that length I will be incrementing a digits counter as well. Then I have a small letter A to Z, capital letter A to Z, and plus. So this means that any number of alphabets which matches with small a to z and capital A to Z, these all will be taken as a character, and the token, it is going to generate a token, a complete token will be considered as a word. So I will be incrementing a word counter, and the length of a token will be incremented as a length of the character counter. Then the next rule is a negation of space /t and /n. So other than space /t and /n, everything will be considered as a spatial symbol. What does it mean is, other than, this negation says other than space /t and /n, all remaining things are considered as a spatial symbols. These spatial symbols will be counted on that basis. So this is my rules section, and the next part is my actual code. So this code is consist of a file, right? A file which is to be taken as input file. So we'll be taking the input from the user. That file will be opened in a read mode, and the pointer of file is returned to YYIN. This YYIN is a default file pointer which is provided to Lex. So always we need to use this as YYIN, so that our file pointer will be provided to a Lexer, and Lexer will start analyzing a given file. So suppose this file pointer returns null. Suppose this file pointer is null. So it simply means that file has not found, and if it not null, it means that there is a file which we need to analyze, and we need to generate a token for that. So that particular file will be considered and given to a Lexer. So at this point we will start calling the Lexer function. So our file is given as input to a Lex, and now YYLex function will start analyzing the file. Then there is a last function which is called as a YYWrap. It is a wrapper function which says the end of path file. If you are done with the parsing of a current file, it will be returning 1, otherwise it will be returning 0. Now we'll see how this explanation of the code again. So YYWrap wraps the above rule section. YYIn takes the file pointer which contains the input. YYLex runs with main flex function which runs the rule section, and YYText is a text in the buffer. So how does this work? It works as this file is pointed by YYIn. So YYLex is the function which we have to invoke to start the process. When we invoke YYLex, Lex will take the file which is pointed by YYIn and scan input of characters. It tries to match the characters with the regular expression you provided. It keeps the match string in YYText and the length of the match string in YYLength. For each token, it generates a token value which is kept in YYL var. YYL length and YY text will keep on changing on each matching of the pattern. This is very important statement. So once every pattern is matched, it will be pointed by YY text and its length will be given in YY length. So after scanning the whole file, it needs to print the output in a file. So this is YY out is the pointer to the file where it has to keep the output. So this is how the code works. So we have seen the code and we have seen the explanation of the code. Now one by one we'll see the output of the code. So how does this how to compile the code? So we can compile code by using lex. The code is a count, so lex count.l. This lex count.l is going to generate a output file which is called as lex.yy.c. So we need to compile this file with a GCC. So cc lex.yy.c, and then we are going to link it with the -l option. So now it is going to generate a.out file. So once it generates a.out file, we'll be executing this a.out file. Once after the execution of a.out file, we have seen in the code it asks for the enter the file name. So here in the output we can see it says enter the file name. So I have created one more Java file which can be given as a input file. So this is my one more Java file which is given as an input to this Lexer file to count the given things. So once I give this input as welcome.java, it starts its lexing is analysis phase. So you enter the file here, the file handle is given in YYIN, and as we have seen here, this YYIN is it's given a file to the YYLex, and YYLex start scanning the stream of the characters and start matching with the regular expression which we have provided. So what happens is a welcome.java is given to YYLex, and now YYLex will start analyzing this welcome.java according to the rules which we have given in the rules section, and then it will be generating the tokens. So this is the output. So we can see the output as numbers is equal to 1, digits are 4. So you can see it very well from here. So it is saying welcome to 2020. So your number is 1, and the number contains digits as 4. Similarly, there are tab spaces are 5, there are 67 characters, words are 13, spaces are 6, number of lines are 7. So this is how we have seen how we have tokenized our input file. It is a first phase of compiler, which is a lexical analysis phase, which takes the input as .l file, and then this .l file will be converted to a lex.yy.c file. This particular file takes the input from a user, and then it scans the input file with the rules section, rules given in the rules section for pattern, and accordingly it generates the output. So our first program, which is a B2, which is a B3, which is write a program using lex specification to implement lexical analysis phase of compiler to count number of words, lines and characters of given input file, is over. Thank you all.